back. So we're here in the midst of radical expressions again, and we're going to be doing multiplying radicals today. And the idea with multiplying radicals is just an extension of simplifying radicals, where in simplifying radicals it was something like the square root of 50, and to simplify that you can write this as a product, which is the square root of 25 times 2, which is equal to the square root of 25 times the square root of 2. So multiplying radicals, there is a multiplying radicals expression right there, and it doesn't help in simplifying to use this as an expression, but the point being is that when we were simplifying radicals, we got a couple of factors of radicals, or factors of the radicand, which is the term that's in the radical, and then wrote it as a product and then broke it apart. This is just the reverse of that process, where you take the radicand in both expressions and multiply them together, and there you go. That's the product of radicals. But subsequently, when multiplying radicals, the idea is then to continue with the simplification process. And there is one reasonably important radical multiplication subsequent simplification step that is about to show up, because it shows up more often. Oh, that's hot. And that would be one that looks just like this. So you have the square root of 6 times the square root of 6. And this was on the sheet, the worksheet that I gave you all today. And most of you figured it out immediately. Where you go, okay, that's then you took this idea and multiplied the two radicands, the term under the radical, and said, well, that's just the square root of 36, which is exactly correct. But then pursuant to that, the square root of 36 is 6. So the idea is that I would like you to get is when you have the square root of 6 times the square root of 6, to be able to go right straight to 6, or the square root of 5 times the square root of 5 is 5, and the square root of 17 times the square root of 17 is 17. Alrighty then. Ooh, that's hot, but it's good. Let's get a new writing slate and go for it. So let's see here. I've got an example that says 3 root 12 times root 6. Which can be written as, or is equal to, 3 times the root of 6 times 12, which is 72. Then you, again, it's like, alrighty then, what can I do? What is a factor of 72 that is a perfect square? I don't know. Fine. 72. 36. 36. Where's Josh when you need him? So that would be equal to 3 times the square root of 36 times 2. Then I'm going to use the reverse process of multiplying them together. I'm going to break that little piece apart right there, which is equal to 3 times the square root of 36 times the square root of 2, and that's equal to 3 times 6, because the square root of 36 is 6, times the square root of 2, and 3 times 6 is 18, root 2, and we're done. Say hallelujah. Okay then. Let's see, what have we here up for bids? Got root 5 times root 10, which would be equal to root 50. And that's equal to the square root of 25 times 2, which is subsequently equal to the square root of 25 times the square root of 2, which is the square root of 25 is 5, and the square root of 2 is the square root of 2, so that would be 5 root 2, and we're done. Do. Let's see here. How about negative 4 root 15 times the negative, or negative root 3. I'm going to put that in parentheses because there's an operation right there which is multiply, and an operation right there which is subtract. And if protocol is being followed, there should be a parenthesis between those two operations. So now I'm just going to start multiplying things together, and I'm going to multiply the number in front of the radical first. So negative 4 times negative 1 is 4, and under the radical is 15 times 3, which is 45. Now I'm going to see if I can simplify this square root of 45. So that would be 4 times, let's see, 9. 9 times 5, which is 4 times root 3 times root 5. No, pace. I'm thinking of the answer right there. That would be root 9 right there. Now I get a 3. That would be 4 times 3 times root 5, and 4 times 3 is 12 root 5, and we are done. Let's see. I've got one that's a little more complicated right there. I don't want to get too far into these because we'll get into those when we add and subtract. So I've got 2 root 5 times quantity root 6 plus 2. And this is just a distributive property problem. So you take the 2 root 5 times the first term and 2 root 5 times the second term, and 2 times that 1 right there. Do you see it? 2 times 1 is 2, and root 6 times 5 is 30, plus 2 times 2 is 4, and root 5 times 1 right there is root 5. Then, can I do anything with 30? 10 and 3, 5 and 6, 2 and 15. Mickey, leave me be. I believe that's it. This one won't. This square root of 30 won't simplify, so we are done. And that's it. So in multiplying radicals, and there's on the sheet I gave you today, there's some reasonably wicked problems, and I'm not going to get into those just yet. If you wanted to show off and figure them out, then I'm going to be duly impressed, and would even certainly be able to talk someone into giving them bonus points for having done something like this. 3 root 2 plus 2 root 3 times quantity root 5 minus 3 root 3. I don't know, something like that. You got this big old freaking mess. And you figure that one out and come up with all that stuff. I will bonus point you. How's that? It won't be long till I won't bonus point you, but when we get into and up to the world of Adding adding and subtracting radical expressions, that kind of thing would be fair game. It's a little tough at the moment. So, with multiplying radicals, the first key point is the square root of x times the square root of x is x, which can be, the x can be replaced by any number. So the square root of 2 times the square root of 2 is 2. And that comes into play in dividing radicals. It's kind of a handy little fella. And then beyond that, the idea being the square root of 6 times the square root of 10 is equal to the square root of 6 times 10, which is equal to the square root of 60. So you can just multiply the terms under the radical and then proceed with subsequently trying to simplify the radical again, just like we have been doing. Okay then, we're off. Take care then. Bye-bye now.